Good afternoon to all of you. Just a minute. Okay. So, in our today's topic of discussion, we are going to discuss on the topic of PGP, right? So, we are going to talk on the topic of PGP. So, this PGP is meaning as pretty good services. So, pretty good privacy. So, in the era of this network, and all of the things are we are dealing in the situation of COVID, we are dealing with all the things in online, right? Starting from e-marketing, e-medicine, right? Checkup, e-checkup, banking transactions, and there are much more, etc. I said everything, each and everything we are going to deal with the network. So when 80 to 90% things of our life are we are dealing with the network, the data security, the term security of the data is an important thing that we need to think about. So we are sending an email, right, from our desktop or phones. This email also needs some security. So this PGP, the pretty good privacy, provides the confidentiality and authentication services that can be used for any type of electronic mail and file storage application. So PGP provides the confidentiality. PGP provides the confidentiality and authentication services that can be used for email and storage. That can be used for email and storage, right? So this PGP, it has some steps. So what are the steps involved in PGP? We need to think about what are the steps that is involved in PGP. So steps involved in PGP. What are the steps involved in PGP? So what is that? The first we need to select the best available cryptographic algorithms as building blocks. The first step is we need to select best available cryptographic algorithm. First, select best available cryptographic algorithm. Select best available cryptographic algorithm, right? Second, integrate these algorithms into a general purpose application that is independent of any platform. Platform means any type of operating system, processor, and that is very easy and based on small set of easy to use command. So we need to integrate these algorithms into a general purpose application. Then we need to make a package and its documentation, including the source code, freely available bulletin boards and commercial networks, right? So we need to make a package and its documentation, and last enter into an agreement with any type of companies to sort it out actually who needs it for this PGP. So this PGP actually grown rapidly and now used widely. The number of reasons, there is many reasons actually for its growth, why it have growth so much. The reasons are, we can say it is available free worldwide in every version and run on any platform. So this PGP It's freely available. Pretty good privacy is available freely, and it can run on any platform on any version. Second, it is based on the algorithm that have survived extensive public review, and it is considered as extremely secure. Like our RSA algorithm, DSA algorithm, DSA definitely Hellman, public key encryption. There are 3DSS, several type of algorithms are present, and that's why the PGP has grown extremely, and it has a wide range of applicability. So this PGP is very much popular and very much important part of this data security and the data privacy. Now, what are the operational description of this PGP? The actual operation, if we are talking about of PGP, it consists of 5 services. PGP's operation consists of 5 services, right? What are those 5 services? First one, authentication. First one is authentication. Second one, confidentiality. Authentication, confidentiality. Third one is compression. Third one is compression. Fourth one is email compatibility. And fifth one is segmentation. So these are the 5 important parts of PGP. There are 5 services. These are the 5 services that is present in our PGP. Authentication, confidentiality, compression, email compatibility, and segmentation. Now, if we discuss one by one, first let us talk about the authentication. What is this authentication? The sequence of authentication, how it follows, means what are the authentication process. First, when someone is trying to be active, considering a sender, the sender creates a message. We are talking about the authentication part. The sender first creates a message. Then SHA-1 algorithm is used here to generate a 160-bit hash code for the message. So SHA-1 is used here for the part of authentication. SHA-1 algorithm is used for authentication, creates a 160-bit hash code of the message. So when the sender trying to send a message, a 160-bit hash code is created with the help of its SHA algorithm to create a 160-bit hash code message. This hash code, then it is encrypted with RSA algorithm using the sender private key, and then the total result is ready or prepared to, or actually prepended as a message. The whole scenario is looks like a message right now. So when this hash code is encrypted with the key, with the sender private key, including the RSA algorithm, then the whole thing is merged and then it is considered as a message. Here, the receiver uses this RSA with the sender public key. The receiver uses this RSA algorithm with the sender's public key, decrypts and recover this hash code. So now coming to the receiver part, the receiver uses against those RSA algorithm with the help of the sender's key, public key actually, to decrypt and recover the hash code. Now the receiver generates a new hash code from the message and compare it with the decrypted hash code. And if these two matches, then the message is counted as a authentic. The message is considered as authentic. So what are the steps? I repeat again. First, the sender creates the message. Next, an SHN algorithm is used here to create a 160-bit hash code of that particular message. Then the hash code is encrypted with the help of the RSA algorithm with the sender's private key, and then the total scenario is considered as a message. Fourth part, now coming to the receiver side, the receiver uses that RSA algorithm again with and getting the sender's public key. Sender's public key to decrypt and recover those hash codes. Fifth, the receiver generates a new hash code for the message and compare it to the decrypted one. And if there's two matches, then it is considered as authentic. Then it is considered as authentic. Right? Now coming to the second part, that is confidentiality. Coming to the second part, that is confidentiality. So this confidentiality, it provides or it is provided by the encrypting messages to be transmitted or to be stored locally as files, to be stored locally as files. In every case, this conventional encryption systems or conventional encryption algorithm CAST128. So what is the conventional encryption algorithm is used here? This conventional encryption algorithm is used here, right? Then the 64-bit cipher feedback mode is used. So first, confidentially, to create the confidentiality, we use the CAST128 encryption algorithm. Then the 64-bit cipher feedback mode is used here. So in this PGP, the pretty good services or pretty good privacy, what we are talking about, the conventional key is used only once. Each conventional key is used only one time. That is why a new key is generated as a random 128-bit number for each messages, and it is referred as a session key, and it is a one-time particular key. To protect this key, it is encrypted with the receiver public key. So the confidentiality is maintained here with two things. First, the encryption algorithm CAST128 is used here. Secondly, the 64-bit cipher feedback technology is also cipher feedback algorithms is also used here to provide to confident the data. Now, what is the sequence? What are the steps that is followed in this confidentiality part? The sender generates the message and a random 1-bit number is used as a session key for the message only. So here the sender is creating a message or generating a message, and a random 128 number is to be used for a session key to generate this message only. Now, this message is encrypted using 128-bit number to be used, and for a session key, this CAST128 with the session key message is encrypted again, and the session key is encrypted then with the help of the RSA algorithm using the receiver public key and totally appended as a message. And the receiver uses this RSA with its private key to decrypt and recover the session key again. Right? So this authentication and confidentiality. The confidentiality and authentication are both actually interlinked with each other, and cryptographic algorithms are helping them to do the scenarios. Now coming to the third part, that is our compression. Coming to the third part, that is compression. So as a default, this PGP compresses the messages after applying the signature before the encryption process. So this PGP compresses the message after applying the signature, but before that encryption process. So this has a benefit of saving space for both email transmission and for file storage. The preferable is here that compressing the messages before applying the signature with encryption. Right? So compression is compressing the messages after applying the signature, but the whole process works before the encryption. Right? Next, coming to the part email compatibility. So the electronic mails or many email systems only permits the use of blocks consisting of ASCII text. So emails only permit the use of blocks consisting of ASCII text, right? So to accommodate this particular restriction, PGP provides the service of converting the ASCII text into a 8-bit binary string. Into a 8-bit binary string. So this PGP provides services of converting this or 8-bit to a partiable printable ASCII character, and the scheme is used for the purpose is radix 64 conversion. So email compatibility, what is used here? Radix 64 conversion. The scenario that is used here, radix 64 conversation. Now each of these group of 3 octets of binary data is mapped with the ASCII character, and then it is followed by the process. And lastly, segmentation and reassembly. Segmentation and reassemble that facilities are restricted with a maximum number of lengths. So this is accessible through the internet. It is accessible through the internet with different small segments, and the segmentation are done after all the processing, including the Radix 64 conversion. And this PGP must strip of all email headers and reassemble the entire original box before performing the other step. So these are the 5 components that are present into the scenario. What are those? Authentication, confidentiality, compression, email compatibility, and segmentation. Now, the next part, that is the cryptography keys and the key rings. So, talking about the cryptography keys and key rings. Wait a minute. This cryptography keys and the key rings, there are 3 separate requirements can be identified with respect to this keys. Means generating unpredictable session keys is needed. Generating some unpredictable session keys is needed here. allow the user to have multiple public and private key pairs, and PGP must maintain a file for its own public and private key pairs as well as the file of public key correspondent. Now, what are the requirements? We just said that to proceed with the cryptographic keys and the keys, there are some requirements is needed. What are those requirements? First, the session key generation. First requirement is session key generation. What happened here? That each session key is associated with a single message and is used only for the purpose of encryption and decryption of that particular message. So session key is associated with a particular single message and it is used only for the purpose of encryption and decryption of that particular messages. So randomly any 128-bit numbers are generated using any cache 128 itself, and the input of this number consists of 128-bit key and 264-bit blocks are treated as plain text of this ciphertext or this encryption process. Right. The second requirement is the key identifier. The second requirement is that key identifier. So if multiple public or private keys are pair are used, then the recipient, how it will know that which of the public keys was used to encrypt the session key. Similarly, it is a very basic question. When there are several type of keys, several type of uh, processes are there, then how we can find or how the system will find that which key is used here for the encryption processes. Which one is the session key? The simple solution for this to transmit the public key with the message, right? The simplest solution to transmit the public key with the message, but it is unnecessary or wasteful of us, because if it is does not match, then the space will be wastage, right? So the next solution would be to associate an identifier with each public key that is unique for list within each user, right? So the list public key that is actually common within many of them is used here. So this messages consist of 3 points: message component, signature component, and third one is all about session key component. So what are the components? Message component. So these are the components: message component, signature component, and session key component are used for this uh, process. So message component, it includes actual data that needs to be transmitted, as well as the file name and the timestamp that specifies the time of creation. That specifies the time of creation. Next, the signature component that includes the following: timestamp, message digest, and to detect any of the message digest. Mhm. So this message signature component has a timestamp when the signature was made. Message digesting means some hash code and octets of this message digest to enable the recipient to determine if the public key was used to decrypt the messages. So which one is used for which thing? timestamp. So first one, timestamp, time when the signature was made, right? After the timestamp, second one, the message digest, that is equal to hash code. Third one is that octets of the message digest, octets of the message digest. That is to enable the recipient to determine if the correct public key was used to detect the or to decrypt the messages. So it is used to enable the recipient to determine the correct public key was used to decrypt the messages, right? And lastly, the fourth one, that is the key IDs of the sender public key that identifies the public key. Key ID of the sender's public key that identifies the public key, right? So these are the important terms, or these are the four important parts in this particular scenario. Now, after this, the session key component that includes session key and the identifier of the recipient public key, includes session key and recipients of the public key, right? So session key components, it includes the session key and identifier of the recipient public key. Lastly, the third, it is key rings. A PGP provides a pair of data structures and each node wants to store the public or the private key pair owned by that particular node, and also want to store the public key of the other users known as that particular node. So the data structure are referred to as private key and public key. So these data structures are referred as public key and private key. So these general structures of this private key and the public key, there are two parts, that is timestamp and key ID. Public key portion of this pair, private key is the private portion of the pair, and user ID is the owner of the key. Right. So there a signature trust field indicates the degree to which this PGP was user trust the signer to certify public key. So owner's trust field and message generation is the part. So how this PGP message generation, how the message generation was done in PGP. So this PGP retrieves the sender private key from the private key ring using user ID as an index. So PGP retrieves the sender private key from the private key ring using user ID as an index. And if this user ID was not provided, the first private key from the ring is retrieved. Right? So this PGP prompts the user for this password and to recover the unencrypted private key. Secondly, encrypting the messages, PGP generates a session key and encrypts that particular message. Retrieve the recipient public key from the public key ring using user ID as an index. Next, there are parts encrypting the messages, decrypting the messages, authenticating the messages, public key management. So what are the approaches to public key management? That the problem in this, that user must build up as a public key, the user must build up a public key ring containing the public keys of other users to incorporate with them using that PGP. So A key rings contains the public key attributed to B and the key is owned by the C, right? So there are several processes, the uses of trust. These things are present into this particular PGP for sending the messages, for sending that particular message, right? After that PGP, there is the part that is called S-MIME. The full form of SMIME, Secure Multipurpose Internet Mail Extension. Secure Multipurpose Internet Mail Extension. Right? So this is another portion for this security, the SMIME. It is also a security enhancement to the MIME, the Internet Email Format Standard, and based on some data security. So this multi-purpose internet mail extension, MIME, the full form, the multi-purpose mail internet mail extension, it is intended to address some of the problems and limitation of this SMTP. SMTP is a protocol, the full form of SMTP, Simple Mail Transfer Protocol, and or some other mail transfer protocols for any electronic mail. So what are the limitations of this SMTP and other protocols? That SMTP cannot transit or transmit executable files or other binary objects. SMTP cannot transmit executable files. SMTP cannot transmit executable files and also any other binary objects or other binary objects. So this is the drawback of SMTP or any other transfer protocol, that it cannot transmit executable files or any other binary objects. It cannot transmit text data that include some characters because these are represented by 8-bit codes. So I'm talking about the limitations. What are the limitations? So it cannot transmit text data. It cannot transmit text data. Next, what is the limitation? That its servers, SMTP servers, may reject mail message over a certain size. So the size limitation, SMTP has a size limitation, right? Next, we can say the gateways that translate between these do not use a consistent of mapping or resulting in a translation problem. So we can say translation problem. So these are the limitation: deletion and addition of recording, of carriage return and field, removal of trailing white space, padding of lines in a message. So these are the limitation that is present in our SMTP servers, right? These are the limitation that is present in our SMTP servers. So MIME is intended to resolve this problem in a manner that is compatible with some existing RFC implementation. So this MIME specification includes some following of the elements, that is 5 new message header, number of content formats, transfer encoding. These are the extra added scenario that is present here, right? So MIME, the MIME specification is used for some elements, that is 5 new message header, number of content formats, transfer encoding, content type, content transfer encoding, content ID. So these are the several scenarios are present. Now there is a detailed list of this MIME content types, but we are not going to discuss about this today. We are going to continue the discussion in our next classes. As of now, for today, our class topic will end up to this particular MIME limitation, SMTP limitation, and why MIME have invented, how MIME has come into the scenario to overcome the limitation of this SMTP, right? So this is the scenario, this is the part that we have discussed today, the SMIME, SMTP, the PGP, right? So we are going to stop here for today's part. Now I would like all of you, or requesting all of you, to kindly write your names in the chat box for your attendance purpose, right? So we are going to continue the topic in our next classes. from this particular scenario. So kindly all of you write your names in the chat box for the attendance purpose. Fine. So I hope all of you have written your names in the chat box. So thank you all for joining into the session. Take care and stay safe. We will meet again in next class.